Hey everybody, welcome to my channel. I'm LeetCoder, and today we have a great problem for you guys, right? So it's called find the smallest letter greater than the target, right? So this is a very good one. So let's quickly get into the description, right? So it says we're given an array of characters, right? Letters, and it is sorted in non-decreasing order, right? It says, also given a character target, right? So it says to find at least two different characters and letters. Also, there are at least two distinct characters and letters, right? So it says to return the smallest character and letters that is lexicographically greater than the target, right? So if such character does not exist, return the first character and letters, right? Okay, so this is a very simple problem statement, guys. So they're gonna be giving us two arrays, right? Just two arrays. I mean, one array, right? And then also it could be giving a target, right? So our job, right, is to find the lexicographically greater character than the target, right? So that's kind of what the job is, right? So if we can't find that in the array, right, of characters, we return the first character present in the array, right? So very simple, right? And very simple. So we understand the question. So let's go through an example to even solidify the ask, right? So given this array of letters and also given a target, right? And we need to find the character that's lexicographically bigger, right? So anything that comes after A in the alphabet is fair game, right? So not only that, but we also want the character, right? The smallest one, right? That's bigger than the target, right? So in this case, by looking at it, we see that C is the answer, right? No, F is greater than A, right? J is greater than A as well, right? Lexicographically, right? But they're not the smallest one, right? We want the smallest character that is lexicographically bigger, right, than A. So C fit that constraint. So that's why we went out to C and we returned C, right? It's the correct output. And this is the same concept, right? We're given the target C and we want the character that's lexicographically bigger, right? We can't choose C, right? They didn't say equal, right? They said the one that's lexicographically greater, right? So F fits that constraint, right? You know what I'm saying? So yeah. And then we get another example. We see we're looking for Z, right? And we want the character that's lexicographically greater, right? Obviously, that's not going to exist, right? Because Z is the highest one, right? Therefore, we return the first character in the array, right, to signify that we didn't find anything in the array that fit that constraint, right? So there's no character greater than Z in this array, right? So when we do that, right, so we kind of understand it better now. So what kind of approach can we do for this problem, guys? Right, we could probably do the most straightforward way possible, which is to loop through, do a linear scan, right? Go from left to right. And as we're looping through, right, we do a check, right? An if statement that checks if the current character, the current iteration that we're on, right, is it greater than the target, right? If that's the case, guys, right, we automatically return that first character we see, right? Because it is sorted in non-decreasing order, right? So it's sorted. So we use the aspect to our advantage, right? To just return that first character that we see that matches the constraint, right? Which is lexicographically greater than the target. And that's why the first iteration, we would return C because C fit that constraint, right? The same principle here, right? We look through, we see C greater than C. No, it's not, it's equal, right? So we go to the next one, and the F greater than C, yes, it is. We return it, right? So just like that. And we apply the same thing here, guys, right? So you see that it's very simple, right? That's a very good start. If you're in your setting to start off with that solution, right? The brute force solution, right? Will be O of N, right? So we could do a little bit better, right? We could use the sorted aspect, right? No, anything sorted. Normally we have to apply some kind of a binary search, right? So you see the beauty of it. We need to find a way to kind of apply a binary search to the array, right? So how we're gonna apply binary search, guys, is gonna be the same way we do it when we have integers, guys, right? We do comparisons and discards half of the array every iteration, right? And then efficiently search, what I'm saying, the right part that we care about, right? Instead of searching, do a linear thing and searching every single character, right? So this is how we do it, right? So how it's gonna work, we do a check with the midpoint, right? So initially the search space is the whole array, right? And then we check the midpoint against the target and we decide to go left or right depending on the value of the midpoint, right? So it's gonna be very simple. So we check the case if the value at the midpoint is less than the target, we go to the right, and if it's the midpoint is greater than the target, we go to the left, right? That's how simple it's gonna be, right? And also we're gonna do also a check, right? If the midpoint equals to the target, right? We go to the right as well, right? Because we go to the right guy because we're looking for a character that's greater than the target, right? And that's why when the midpoint is less than the target, we go to the right as well, right? Because we were looking for characters that are greater than the target, not less, right? So this is the beauty of it, right? This is how we're gonna implement it. Hopefully it makes sense to you guys, right? And then when we exit out the while loop, right, you'll see how it works out. The left character should be pointing at the lexicographically greater uh, character, right? If the left pointer is out of bounds, right, then we know that we weren't able to find a character in the array that fit that constraint, right? So we're gonna return the first character in this, right? So let's go through a quick example. So we do a check, right? Is F is greater than A, right? Right. So we go to the left and we check is A is C greater than A, right? It is greater than A. So the right pointer will go to the left, right? Go out of bounds. Then we know we exit, right? But the left pointer is pointing at that C, right? Which is the right thing right here, right? So to go through this example, right? You'll see it makes sense. It works as well, right? We check. Is F greater than C? Yeah, it is. So go to my left, right? My left, you check C. Is C greater than C, right? No, it's not, right? So I go to the right. So the left pointer goes here, and then the left pointer is pointing here, right? So hopefully you guys understand when I say go to the right, right? We update the left pointer to mid plus one, right? And I say we go to the left, we update the right pointer to be mid minus one, right? So hopefully it kind of makes sense, right? And so this is how the algorithm works, guys, right? By cutting the search space in like that, right? So yeah, so let's go quickly implement that. So we got our left pointer, guys, initialize to 0. We got our right pointer, letters that length minus 1. So essentially the whole array initially, right? And we're gonna do what the left is less than the right, and mid left plus right minus left divided by 2. Then we do our checks right here, guys, right? Very simple binary search template, okay? So we do a check if the character at the mid, right, is it less than or equal to target? If it is, I'm gonna go to the right, right? Search my upper half, right? This is how we do it. We update the left pointer, right? On the other cases, if it's greater, then we update our right pointer to be mid minus 1. And then we do a simple check here, guys. If the left pointer is it's less than, right? That means I was able to find, right, the letters element. If it's less than, I can simply just whatever character is pointing at, I refer to it. If that's the other case, then we return the first um, character in the thing, right? In the array. So let's press run code. They work good. That looks good so far, guys. Let's press submit. Awesome, guys. We're able to pass all the test cases, guys. So if you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.